Today let's talk about ordered pair. When we studied analytic geometry, we convinced ourselves that after one has chosen an x-axis and y-axis in the plane, every point in the plane can be made to correspond to a unique ordered pair x, y of real numbers. In more sophisticated treatments of geometry, the plane is more likely to be defined as the set of all ordered pairs of real numbers. It raises a question: how to define an ordered pair? The Kuratowski ordered pair of x, y, with x being the first coordinate and y being the second coordinate, is defined to be the set x x, y and is denoted by x, y . That is, we have this expression. It defines the ordered pair as a collection of sets. The first coordinate of the ordered pair is defined to be the element belonging to both sets. So we have x belonging here and x belonging here. And the second coordinate, y, is the element belonging to only one of the sets. That is the sets here. We have a theorem. Bracket a, b equals bracket c, d if and only if a equals c and b equals d. Proof. We first prove the right to left direction. If a equals c and b equals d, then we have bracket a equals bracket c and bracket a, b equals bracket c, d. Then we will have this expression, and finally we have this expression. It's simple. Now we prove the left to right direction. Now suppose bracket a, b equals bracket c, d. We have two cases. Either a equals b or a is not equal to b. So in case 1, we assume that a equals b. Then bracket a, b will be a set containing only one element, which is a. How to deduce this result? When a equals b, we have the expression like here, and the second a is already a duplicate. So we finally have this result. And we have this result by the definition of c, d. We have this expression. So we have bracket a equals bracket c equals bracket c, d. So we have a equals c and a equals d. As we know that a equals b, we have b equals d. Case 2, assume a is not equal to b. As bracket a, b equals bracket c, d, we have this expression. When we are matching bracket a to these two sets, inside this bracket set, we have either bracket a equals bracket c, that is, this corresponds to this one, or bracket a equals bracket c, d, that is, this correspond to this. Suppose we have this statement, then we know that a equals c equals d. So we have this set is equal to this set. We have this expression and we have this expression, so we know that these two sets is the same. So we have this result. And then we know that bracket a, b is equal to bracket a. So we have a equals b. But a is not equal to b. Contradiction arises. So we have this result. Therefore, we know that this is the remaining one which is true. Then bracket a is equal to bracket c. Then a is equal to c. Similarly, we know either bracket a, b equals bracket c or bracket a, b equals bracket c, d. Suppose a, b equals bracket c, then we have a equals b equals c. But a is not equal to b, so contradiction arises. So we have this result. Therefore, the remaining one is true. We have bracket a, b equals bracket c, d. From the previous page, we know that a equals c. So bracket a, b equals bracket a, d. Either b equals a or b equals d. But because we know that b is not equal to a, so we have b equals to d. So we have proven this theorem. Ordered triples. Let x, y, z be objects. We define the ordered triple of x, y, z with first, second, and third coordinates being x, y, z respectively to be bracket bracket x, y bracket, z bracket. We write it as bracket x, y, z. That is, we have this expression. An ordered triple is defined to be the way like this because we can use it to define what a function is as an ordered triple. This will be discussed in the next video. Finally, we arrive at the Cartesian product of two sets. The definition: let A, B be sets. The Cartesian product A cross B of the sets A, B is defined to be the set consisting all the ordered pairs x, y for some x belonging to A and y belonging to B. We can refer to this picture to explain what a Cartesian product is. That is, we have this definition. This is the end of this video. If you find the video interesting, please consider subscribing to this channel, liking the video, and leaving your comments down below. See you in the next video. Thank you.